So welcome students. In this question you have two relations. S is a relation which connects x and y if y is equal to x plus 1. And T is a relation which connects x and y if x minus y is an integer. So you are asked to check the equivalence nature of each of these relations. First let us go for S, the relation S. So if you want to check the equivalence nature of S, let us first start with reflexivity. So if you take any element x comma x, if you take any set, any pair of the form x comma x, will x and x, will this always belong to S? That's the question. So if you want to answer the reflexivity, you should check whether each element is related to itself or not. Each element is related to itself, but the relation is y is equal to x plus 1. So if you take 1 comma 1, so let us take 1 comma 1. Will 1 comma 1 be related? Will 1 be related to 1? No, because the nature of the relation, the condition for relation is y should be equal to x plus 1. So we can see that 1 is not equal to 1 plus 1. Hence 1 comma 1 does not belong to the relation S. Hence S is not reflexive. So if S is not reflexive, obviously it won't be an equivalence relation. Not equivalence. It's not an equivalence relation. Now let us go to T. So let us first check reflexivity. So x will be related to y if x minus y is an integer. That is the nature of T. That is the condition for T. That's the definition of T. So if x is to be related to y, x minus y has to be an integer. So for reflexivity, I'll check for x comma x. Will x be related to x? Yes, because x minus x is equal to 0. This always belongs to integers. So x minus x always is an integer. So every element x will be related to itself. So if you take symmetry, if x comma y belongs to T, that means x minus y belongs to z. That means y minus x also belongs to z. Because if x minus y is an integer, y minus x is also an integer. Hence y comma x also belong to the set, the relation T. Hence if x comma y belongs to T, y comma x also belongs to T. Hence it is symmetric also. If you go for transitivity, so you have to assume xy and yz belongs to T. This implies x minus y is also an integer, y minus z is also an integer. So this is an integer, this is an integer. So can I say that the sum of these two is also an integer? That is x minus y plus y minus z is also an integer. So y and y gets cancelled. So this implies x minus z is also an integer, right? X minus y plus y minus z is also an integer. Hence x minus z will also be an integer. This implies x comma z belongs to the relation T. So xy, yz belongs to T implies xz belongs to T. So the relation is transitive also. Hence this is an equivalence relation. So what is your final answer? S is not equivalence and T is equivalence. Thank you.